Hello to all your students. In this video, we'll be discussing about a topic of data graphics, that is histogram. So first of all, what is a histogram? Histogram means it is a representation of a frequency distribution by means of rectangles whose widths represents class intervals and whose areas are proportional to the corresponding frequency. So it looks somewhat like this, just like bar graph, but this is not bar graph, these are the histogram. So as you can see over here, the rectangles you can see, so the width mainly represents the class interval and the areas are proportional to the frequency. So width means whatever you can see on the x-axis, whatever width is there, it will represent the class interval and the height will be the frequencies. Next, why are histograms used? Histograms are an important tool for visually representing a data distribution. These charts summarize large quantities of data and represent the frequency of values. Therefore, they aid in determining the data distribution trend and medians. They are also effective in highlighting the gaps and outliers in data. So as you can see over here, in the histogram, the representation will be such that you can easily get what you need to know. Means apart from all the numericals, you can visualize the thing very easily. It will be more highlighting over there. Next, when to use a histogram. A histogram can be used when you want to show the distribution of values of a data series, condense large data values into compact graphical representations, compare the process results with your specified limits and gauge whether it will fulfill the requirements or not, compare the outputs of two or more processes and make a decision based on the output of a process. Next, we should see the elements of histogram. So, a histogram is made up of four main components. They are title, horizontal axis, that is the x-axis, vertical axis, that is the y-axis, and bars. So we can check out it one by one. First of all, title. So title, this marks out the information included in a histogram. That is the title. Next comes the horizontal axis, or you can see the x-axis. This represents the intervals the data is divided into. The intervals are uniform and help in summarizing a large number of data sets. But here individual data are not displayed, only ranges will be there. Next is the vertical axis, or you can see the y-axis, and it represents the frequency of the data plots, which is the number of times a value occurred in that interval. So that is vertical axis. And lastly, coming to bars. The bars have variable height and width and are used to represent the data plots. The height corresponds to the frequency of a value, while the width represents the length of the interval. Now we will check out one simple example by which you can get to know all the things in the histogram. So there is an example. Histogram is plotted for the height of cherry trees in a garden. The garden had 30 trees and the height was measured for each of them. The data is then grouped in the form of a frequency distribution chart that sets the intervals and records the frequency for it. So as you can see, what we are plotting a graph to know the height of the cherry trees, and we have got totally 30 trees, and the height you can see in the tabular column, ranges are there like 60 to 65 feet, such kind of height. We have got 3 trees of this much height. Next 60 to 70 feet, we have got 3 more trees. 71 to 75 feet of height, we have got 8 trees. 76 to 80 feet of height, we have got 10 trees. 81 to 85 feet of height, we have got 5 trees, and the height range of 86 to 90 feet, we have got just one tree. So this is a tabular form, but it is very easy to will be more understandable if we make a histogram of it. So first, starting with our this thing, so you can see upside we have made all the problem the thing, and below you can see table, and on the right side I have made a graph paper. So first of all, coming to the title, what must be the title? Yes, height of the black cherry trees, that is the title. Next is the horizontal axis. Horizontal axis means the x-axis. So as you can see, on the x-axis it should be the height range. Okay, frequency will be on the y-axis. So the range will be on the x-axis, and you can see the range is starting from 60 to 65, 66 to 70. So we can use 5 feet of height for 1 unit. Okay, so 1 unit equals to 5 feet, but as you can see it starts with 60, so we can make it from 60. Okay, so this is the x-axis and these are the values. Okay, so on the x-axis is the height in feet, and 1 unit is equals to 5 feet. So this is the horizontal axis. Next, coming to the vertical axis, that is the y-axis. Okay, so on the y-axis we have got frequency, that is number of trees. So you can see the maximum number is 10, so we can use 1 tree for 1 unit. Okay, so 1 unit is equals to 1 tree you can make. So you can make notation somewhat like this. So this is the vertical axis. And lastly, coming to the bar. So as you can see, the height range of 60 to 65 feet, we have got 3 trees. So make a like this, a bar like this. Next, height of 66 to 70 feet, we have got 3 trees. Fine. Next, height of 71 to 75 feet, we have got 8 trees. So over here 8. Next, height of 76 to 80 feet, we have got 10 trees. Next, 81 to 85 feet, we have got 5 trees. And lastly, 86 to 90 feet of height, we have got just single tree. Okay, so you can see it is very easy to understand. Okay, maximum, most of the trees have got height of 75 to 80 feet range, means almost 10 trees. Among 30, 10 trees have got the height of 75 to 80 feet. So it is very easy to visualize as such. Next, we shall check out the advantages of histogram. Advantages are: it displays large amount of data that are difficult to interpret in a tabular form. So as we have seen in the previous example. Next, show the relative frequency of occurrence of the various data values. This is also proved in our previous example. Next, reveal the variation, centering and distribution shape of the data. Next, very useful when calculating capacity of a process. Lastly, helps predict future performance of process. So these all are the advantages of histogram. Now when advantages are there, disadvantages will also be there. So they are somewhat like this. Individual data values are not visible, means they are lost. Cannot represent all the details, only represent approximation of data. And lastly, it is a supplement, not an alternative to tabulation form. So these all are the advantages and disadvantages of histogram. And with this, I end up my video regarding histogram. I hope you people found my video helpful. Thank you for watching.